All right, hello grade 12s. We're going to move into our second part of the review for this learning block. And this is where we're going to do some basic chemistry review from grade 11. I'm going to go over a couple of topics and spend as much time or as little as you need on this. But this is a good page where it'll remind you how to do some stoichiometry, how to figure out the solubility rules. It'll also go over how to calculate your molar mass and how to remember the gas testing rules. I know we already reviewed those on the periodic table, but here is a great page that you can use as part of your summary notes. Okay, so here we go. This is basic chemistry from grade 11. We're going to start with a chemical equation, but you're going to be given it in words, okay? An excess of sodium bicarbonate, NaHCO3, is going to react with 18.2 grams of concentrated sulfuric acid. The one product, a colorless transparent gas, is tested by bubbling it through lime water. A white precipitate is formed. The first thing you think about is that because both of the reactants are compounds, the type of reaction that you're going to have is going to be a double displacement reaction. Okay? Why? Because they're both compounds. I have my NaHCO3. My state is a solid. I have my H2SO4, and again, that's our nomenclature practice, that sulfuric acid is, remember, SO4 with a 2- charge, so sulfuric acid has simply 2 hydrogens attached, and then don't forget that you're going to make sure you've got aqueous as your state, because that means it's a solution. Okay, now then I have my products. First of all, it says I've got a white precipitate. I know that that's going to be my ionic salt, if you will, and because it's double displacement, I'm going to go with sodium sulfate, and of course, I put an S because of the fact that it is a solid, and the question tells me that it's a solid. Then I know I have a transparent gas that bubbles through lime water, and I'm going to tell you that the other compound you're going to make is H2CO3. It is unstable. It's going to get broken down into 2 products, one of which is the carbon dioxide gas. Can you therefore guess what the last product is going to be? H2CO3. Water, and the state of water is always going to be a liquid, right? The only time water is ever shown as a gas is when it's in a combustion reaction, because then it's obviously higher than the boiling point of water. So then you could put water with the gaseous state. Otherwise, we always write it as liquid. And then, of course, we have our CO2 as a gas. Okay, can I give you a second to balance the chemical equation and then look back up and check your answer? Pause the video if you need to and go. Okay, balancing chemical equations is something everybody's good at by the time they get to grade 11, and so by grade 12 it's pretty easy to count atoms and know what our molar ratio is. Remember, I always think about chemistry in terms of words. So what does that equation mean? If you were to read it out, it would mean that 2 moles of sodium bicarbonate react with 1 mole of sulfuric acid, react to produce sodium sulfate, 1 mole, 2 moles of water, and 2 moles of carbon dioxide. That follows my law of conservation of mass, and the law of conservation of mass is probably the most important thing you did learn about in grade 10, because it means that atoms just can't magically appear. The ratio at which these compounds react is what it is written as, because you have to have the same number and type of atom on the reactant side as on the product side. Do you get that? The same number and type, because the same type of atom gives you the same mass. The same number of that type of atom will give you a total mass for the atoms on the reactant side, and that will be equal to the total mass of the atoms on the product side. So that's your understanding behind balanced chemical equations. Okay, I'm going to leave the unknown underneath of this equation for a second until we get to our stoichiometry. Part C. Based on its ion composition, why will the ionic compound sodium sulfate be soluble in water? Well, it's a solid in this state right here. If I add it to water, and there is water on the product side, how do I know it's going to be soluble? Well, it's going to be soluble because it has a group 1 ion, okay? You're going to memorize this list right here, which is our general solubility rules. We added it to the periodic table, but here's where it is again. You see, important concepts come up over and over and over again. Your general solubility rules is one of those important concepts. Okay, the next thing we need to do is be able to calculate molar mass, okay? Calculating the molar mass is very important that we do it to 1 decimal place. Why? Because we need our numbers to work out so that we all are dealing with the same values and the same number of significant digits. So you're going to promise me that this year, every time you do a molar mass, it needs to be done to 1 decimal place, which means that when you take your values from the periodic table, you need to write them to 1 decimal place. And your molar mass will have the same number of decimal place because essentially you're adding up all of those atoms. That follows your rules for how to calculate the number of significant digits. When you're adding, you keep the same number of decimal places. So my answer will have 98.1 grams per mole. Pull out those rules for significant digits you learned about in grade 11. Make sure you've got them with you and you know how to do those. Next, could you also calculate the molar mass that you need? Let me just finish writing this. Molar mass for CO2, okay? Show me the right format, pause the video, and come back. Okay, and do you get the answer of 44.0 grams per mole? So you practiced finding those atoms on the periodic table, writing them down to 1 decimal place. You cannot drop a 0. I've talked about that before. Because a 0 is a 0, it means that it wasn't a 2, a 4, or a 9. And so your answer is 44.0 grams per mole. Remember, we're going to use units to help us remember what that means. That means that in 1 mole of carbon dioxide, you have 44 grams. So if I had a balloon filled with 44 grams of carbon dioxide, that'd be a big balloon. I would have 1 mole. I would have 1 particle, 1 mole, 6.02 times 10 to the 23 compounds or molecules of carbon dioxide. Okay, you have to remember that that's what that mole means. Remember, mole is a counting number. So I can have 12 bananas. I can also have a dozen bunches of bananas, right? I still have a dozen things, which is 12, but it just depends on what you're referring to, okay? So atoms are so small that, remember, chemists will refer to them as groups, and groups with regards to a mass, because we need to be able to use them in the lab in a way that makes sense. So I can simply picture what 12 grams of carbon would look like if you measure that out onto the electronic balance, and that would be 1 mole of carbon. That would mean I would have 6.02 times 10 to the 23rd atoms of carbon in 1 mole. That's what that unit 12.0 grams per mole means, okay? So that is a little refresher on the moles. And then we also use our molar ratio in our balanced chemical equation, right? So that reads 2 moles of sodium bicarbonate to 1 mole of H2SO4. Those react to produce 1 mole of sodium sulfate, 2 moles of water, and 2 moles of CO2. So it follows the law of balancing chemical equations, the law of conservation of mass. And it also gives me a reference to how many molecules or particles I would need to have in order to create a number of products. So you can use that math interchangeably, and that's why it's really important to think about things in terms of units. What does the unit actually mean? It can help you figure out how to solve any problem in chemistry because you're putting units to those numbers, which means you're putting value and understanding of what that number means, okay? So that's why sometimes math and chemistry can be easier than math, because you're dealing with numbers, but those numbers have a unit, and so it means something. Okay, so once I've got my molar mass, then I'm going to do some stoichiometry. I'm going to use unit analysis to solve this. Please make sure you're always solving your stoichiometry this way. Are there other ways to do it? Yes. This is the way they will teach you at university, and this is the easiest way, so this is the way we're going to do it. You first write your given down underneath the balanced chemical equation. You have to do it this way. Why? Because it helps you figure out the steps you need to calculate the mass of the gas produced. Okay, so I'm going to go back up here to my balanced chemical equation. I'm going to add in here the numbers that I was given, 18.2 grams of sulfuric acid. That's going to be written right underneath of my sulfuric acid. Okay, I have 18.2 grams of sulfuric acid. The question says, what is the mass of the gas produced? My gas is the carbon dioxide. I'm going to first calculate the number of moles that 18.2 grams is. Then I use my molar ratio of 1 to 2 to calculate the number of moles of CO2 I can make. And then step number 3 is where I take the number of moles of CO2 that I have and calculate the mass. How much is that in terms of moles? Okay, this is my X, this is my unknown. I go back to do my stoichiometry and I start this way. Okay, I need to figure out how many grams of CO2. People always wonder, where do you start? You start at the starting point, the value that you were given. You were given 18.2 grams, so that's where I'm going to start. 18.2 grams of H2SO4. You write it all out. Step number 1, I figure out how many moles I have. To do that, I need my molar mass. To see the units grams per mole, that tells me that my gram is going to be here and my mole is going to be here. Grams of H2SO4 per mole of H2SO4. Okay, therefore I know that my 98.1 goes beside the gram. 98.1 per 1 mole. Okay, pause the video if you don't understand that, but I want you just to look at the units. That tells you how many moles of H2SO4 you will have if you have 18.2 grams. Again, you're using your units. You're canceling out the units because you would cancel the gram on the top and the gram on the bottom. If you solved step number 1, you would be finding out how many moles of H2SO4. Because we're doing a stoichiometry problem, this is only step number 1. I can do it all in one line, and I want you to do it this way. Okay, let's just go back for a second up to our equation. This is where I have, oh, there we go, waking up again. This is where I have my molar ratio. I have 1 mole of H2SO4 makes 2 moles of CO2. I use my coefficients to write down the number of moles of CO2 I'll be able to make based on the fact that it's a 1 to 2 ratio. I always start with my units first, and then I put in my molar ratio. It's easy that way. Watch. I know that I need to have the unit that's mole of H2SO4 on the bottom, so that when I multiply it across, I'm canceling out units, top, bottom, top, bottom. So therefore, on the top, it will be mole of CO2. Now you just look at your balanced chemical equation and put in your coefficients. It was 1 mole of H2SO4 to 2 moles of CO2. You already did that because you balanced the chemical equation. This is now just showing me that if I have, once I calculate the number of moles of H2SO4, I know that they will react in a way that's a ratio of 2 to 1. So if I solved step number 2 here in my stoichiometry, I would then have the answer of how many moles of CO2 does that make. The question doesn't stop there because the question wants me to convert that into a mass. So then I use my molar mass that I calculated for CO2. And again, I'm going to use my units to figure out how I use my 44.0. Am I multiplying or dividing? Start with the units, okay? I know I need a gram of CO2 per mole of CO2 because I need my answer to be in grams. And if I put the mole of CO2 on the bottom, they'll be able to cancel top and bottom. So then I just put my number in, 44.0 grams per mole. Okay, you're going to do the math all the way along, and let's double check that the units cancel each other out. So step number 1, I start with my mass and I multiply it by the molar mass. Cancel the units, cancel the units. If I finished at step number 1, I would then have the moles of H2SO4 that I have. I'm not done. Cancel moles of H2SO4, moles of H2SO4, top and bottom. If I calculated to the end of step number 2, I would now have how many moles of CO2. That would be my unit that would be left over. I'm not done. Step number 3, cancel moles of CO2 and moles of CO2, and my answer will be a unit of grams of CO2. Stop, do your calculation, make sure we've got an answer with 3 significant digits, because 3 significant digits here, 3 here, 3 here means my answer will have 3 significant digits. The 1s and the 2s are just ratios. They are not a measured value. You don't factor in those values into calculating a significant digit. A significant digit is a measured value or a molar mass. It is something that you've actually calculated. Okay, what do you end up with? 16.3 grams of carbon dioxide. Okay, pause the video, practice. That's the only stoichiometry we're going to do for grade 11 review. Do as many more questions as you feel like you need to understand that. And again, if you can explain your stoichiometry solutions, you should be able to do that, no problem. We are going to use stoichiometry in every single unit that we do in grade 12. So this again is your basic understanding of your ratios and how to do this calculation so that we can apply it when we start talking about heat, when we start talking about electrons, when we start talking about solutions. Okay?